So then, can you hear my voice clearly?
Yep, I can hear you.
ठीक है. So, can you hear my voice now?
Yep.
Chalo. अच्छा, so you got Fe2 plus, you got Cl minus 1, and yep. अच्छा, so you got H2O2 acidified. That means it's supposed to have H plus 1 in it. So I'm just going to look for equation for Fe2 plus. So if you open the data booklet, there's going to be two equations, one with Fe3 plus gaining 1 electron in equilibrium with Fe2 plus. The other one is going to be one with, I think, Fe2 plus that gains 2 electrons. And it's going to be in equilibrium with Fe. The first one is 0. Do you have the data booklet with you?
Yep, I have it.
Okay, with Cl2, you got Cl2 plus 2 electrons and 2 Cl minus 1. That's can you find the Fe2 plus electrode value? Jesus, I think it's here. The Fe2 plus 1 is minus 0.44. So this one is minus 0.44 volts, and then H2O2. So you got equations for H2O2 as well. So I need to find H2O2 somewhere, whether it's on the left or right side. Acidified H2O2 preferably. So I think it's do we have H2O2? I think it's over here, H2O2. Plus 2H plus 1 plus 2 electrons. And it's forming 2H2O, 1.77. And then you have, is there another equation for H2O2? I guess. Yep, I think that's it. There is no there is one, this one. So it's O2 plus 2H plus 1 plus 2 electrons. And it's forming H2O2. And this one had a value of this other one, 0.68 volts. Now again, you're gonna look for the highest one. So the highest is, and I'm gonna mark my reactants. So I have Fe2 plus, Fe2 plus. I got Cl minus 1. I got H2O2 acidified, and I've got one where there's just H2O2. So this one, and we can then find the highest, which is this one. Sorry, this is not the highest. 1.771 is the highest. And that gains electrons, and that works because we've got our reactants, right? Is that clear?
Yep, it's clear.
So Bin Salome, find out which one is the lowest one. Like, who's going to lose electrons?
Is it the first one?
He gets rid of the first one. So that's going to come out to be your lowest. So there were two previous candidates, but so why not this one? The 0.681. I mean, then I mean that's a possibility. I mean, the only reason I think we should ignore it is that H2O2 was acidified. So H2O2 had H plus one going along with it. We could have I think we could have had a disproportionation reaction as well. Like H2O2 was also losing electrons at the same time. And but probably the reason why that's not really going to happen is that since our reaction is acidified, we already have too many H plus one, so it would be a lot harder to actually. I mean, we didn't actually study this right now. TK, that's the next thing we're going to study. But the problem with the acid is on the other side, so that will push the equilibrium further to the right. So the H2O2 would not be able to lose electrons because there is already too many H plus one ions. Whether do you get the point?
Yeah.
So minus 0.44 was out of the question because you had Fe losing electrons. That's not going to happen. This can happen, but it will be less likely, TK. Because in the presence of H plus one, because the H plus one is on the other side. So definitely the first one. I say, anyways, but this thing we'll probably study later on, TK, after this, and we can make the overall equation. So I'll just multiply everything by 2, and what I'm going to get is what I'm going to get is H2O2. That's my reactant in the second equation. The first one is 2Fe2 plus. And the product side, you got 2Fe3 plus, and bottom side, that's 2H2O. And you've got your E naught cell, which is reduction minus oxidation, which is 1.77 minus exactly 0.77. So it's 1 volt. TK, whether is this clear?
Yep, it's clear.
I said I'll try doing another one, which is try doing this reaction on your own. You got PbO2 acidified, so there's H plus 1, and I'm reacting it with something. Let's try let's try MgCl2. TK, इसको try doing this one and send the answer for this one. And remember, PbO2 is one thing. This is two different things. Mg2 plus Cl minus 1. TK. ये वाला send करो, you got 5 minutes for this. Okay, so the E naught cell for this reaction came out to be 0.11 volts, which is positive but not very high. So that means it's feasible, but I mean the reaction is going to be slow. You're not going to have a very fast reaction. So remember this, that the E naught cell, if it's greater than 0, that means the reaction is going to be feasible. And the higher the value, it indicates that it's going to be more feasible. An E naught cell of 0 or less indicates that so if it's less than 0 or 0, that means no reaction will happen. So not feasible, no reaction would happen. And instead, a negative voltage indicates, a negative value indicates that the reaction would probably happen in the opposite direction. That the reverse reaction is feasible, not the forward reaction. Okay, so E naught cell less than 0, that means not feasible. So I'm gonna talk about a non-feasible reaction, which is not going to happen. For example, if I write that there's Al that's reacting with NaCl, तो क्या होगा? We know from O levels that a more reactive metal displaces a less reactive one. Al is not the more reactive one, so you should not have any reaction, right? So I'm going to try and do this reaction using the electrode potential values. So for Al, I have this electrode which is given plus 3 electrons, and that's Al. Can you double check whether the voltage for this one is 1.66 volts minus 1.66? Then for Na, it's
Yep, it is minus 1.66.
this one is minus 2.71 volts, and then you have the last one, which is Cl2 in equilibrium with Cl 2Cl minus 1. That's 1.36 volts. So now the idea is that the higher potential is the one that's going to gain electrons. The lower one is the one that's going to lose electrons. So right now, who's the lowest? The lowest is this one, right? So Na is the one that's going to lose electrons, but I don't have Na. So I'm going to just ignore it, right? I don't have Na as my reactant. Who's the lowest now after this one? It's this one, right? Al is the lowest, right? So Al is the one that's going to lose electrons, and I do have Al, so there's nothing wrong with this. So I'm going to go with this one. ठीक है, Varda, is this clear?
Yep, it's clear.
Then I'm going to find the highest one. The highest one is the one that's going to gain electrons, right? So the highest at the moment is Cl2, but we don't have Cl2, so ignore that. Which one is the highest now? The next highest is the aluminum one. But we can't go with that because I don't have Al3 plus as my I don't have Al3 plus over here, so I can't even pick Al. Then what are you left with? Who's your highest now? The highest comes out to be the last one, minus 2.7. That's my out of all the three equations, the only one that's working is this one because I do have Na plus one, right? So is this clear that we figured out the highest and we figured out the lowest? Is that clear?
Yep, it's clear.
And we can write an overall reaction based on this. So this has to be multiplied by 3. And so Al, the other reactant is 3Na plus 1. And the products are Al plus 3. And the other product is 3Na. So we've got a reaction now, which should not have happened because the Al should not displace Na plus 1. So if I calculate the E naught cell, which is reduction potential minus oxidation potential, or even we can do highest minus lowest, right? Reduction potential minus oxidation potential. So it's minus 2.71. That's my reduction voltage. Minus the oxidation potential, which is minus 1.66. This was a calculator. What do you get?
Minus 1.05.
So you're getting minus 1.05 volts. You're getting a minus value, right? So that indicates that it's not feasible. And so it also indicates that basically the whole reaction you came up with was actually incorrect. Because what did we learn? Okay, the highest is the one that gains electrons and the lowest is the one that loses electrons, right? That's what we learned, right? But the thing is, the highest that you're choosing amongst all the three equations is actually not the highest. This is actually lower than this one. So basically, you chose the wrong equation. The highest, the only feasible reaction that you could come up with was giving this as the highest, which in fact it wasn't really the highest, right? So you get the point why this reaction is not feasible.
Yep, it makes sense.
Okay, and the lowest one is actually not the lowest one. It's actually higher than the highest one. So basically, I mean, the only feasible thing or only reaction that you could come up with was actually not feasible to begin with, which is why you're getting a negative potential. So the negative potential basically indicates that you got the highest and the lowest wrong. Or what it also indicates is that the reaction would actually happen in the other direction. The highest is the one that gains it. This is the lowest. Like if you selected these two, the reason you're getting a negative voltage is that the reaction will happen in the backward direction. This is the lowest. So the lowest is the one that's going to lose electrons. So Na should be losing electrons and the top one should be gaining electrons. I mean, the whole reaction should be going in the backward direction. So there is no forward direction. There should be no reaction between them. They can be formed as a product, but they can't react with each other. Okay? So you clear, you can just look at the E0 cell. You get negative, that means nothing would happen. Okay, is this clear?
Yeah, it's clear.
As a similarly, you got some chain reaction. I mean, this is very rare. You get, I mean, most of the questions are going to be relatively easy. So there's something called chain reactions. Now, what happens in chain reactions is that what happens in chain reactions is that it usually deals with reactants involving so it involves reactants that have many oxidation states. So the reaction would probably not happen in one step. For example, if you have tin might turn into tin 2 plus. And then in a separate reaction, the tin 2 plus can turn into tin 4 plus. So your chain reactions are that you're going to have multiple reactions. Like if tin wants to go till tin 4 plus, it's not going to happen in one go. Similarly, elements that have multiple oxidation states. Look at vanadium. Vanadium would first turn into vanadium 2 plus. Then when it turns into vanadium 2 plus, then in a separate reaction, it will turn into vanadium 3 plus. Then from vanadium 3 plus, it will turn into what is this? Plus 4, vanadium plus 4. From vanadium plus 4, it will turn into vanadium plus 5, I think. What is minus 4? It's going to be plus 5. And this is also plus 5. So it might turn into plus 5, right? So it's not going to happen in one go. Elements that have multiple, look at nitrogen, it's got multiple oxidation states. Look at manganese. Manganese goes to plus 2, then plus 3, then plus 4, then from plus 4, I think it goes to plus 7, and so on. The idea clear that there would be certain elements that after the first reaction, there's going to be a second reaction and then a third reaction. Okay? So that's the idea of what a chain reaction is. And I'm going to do an example. Okay. I've got tin and I've got iodine. And iodine is in excess. So, acha, Vardha, pehle first thing, can you try and quickly find out what the reaction is going to be?
So what the product will be?
Tell me what the reaction is between tin and iodine. Like, I mean, the normal way. Do the whole thing again. Try and figure. I mean, it's just two things: tin and iodine, right? So if you just have a look at the data booklet.
Okay.
So if you look for tin, where's tin? There's just one reaction where tin is involved, and there's so iodine is on the other page. Tin is minus 0.14. So there's just one reaction where tin is present. So it's 10 2 plus 2 electrons. I think it was, can you just check, minus 0.14 volts. For iodine, there's only one reaction, that's this one. So easy, the higher one is the one that's going to gain electrons. You got iodine, so that's fine. The lower one is the one that's going to lose electrons. You got tin losing electrons, so that's also fine. So you can just come up with the equation. So tin is the reactant in the first one. In the second one, the reactant is iodine, and the products are first one, it's tin 2 plus, and the second one is 2i minus 1. Okay, so you got your reaction. Is this clear?
Yep, it's clear.
Acha, so that's it. So that's your first reaction. So that's your first reaction right now. Now, after the first reaction, what does your container have, your solution have? It's got these two ions, right? It's got tin 2 plus, and it's got I minus 1. And then there is excess iodine. Iodine was added in excess, so there's some excess iodine that's also left, right? So you're going to try and find out whether there's going to be another reaction after this first one. So you got the first reaction, and now after that you're going to look for the second reaction. So for the second reaction, your reactants are 10 2 plus, and you got I minus 1, you got iodine as well, right? So for iodine, it's the same equation. I mean, for both of them, it's now for 10 2 plus, you've got two reactions now. This was minus 0.14 volts, but for 10 2 plus, there's another reaction which involves 10 4 plus. That's I think 0.15 volts. ठीक है, यहाँ तक clear है?
Yep, it's clear.
Achha, so we're looking for the second reaction. So the higher one is the one that's going to gain electrons. So it's the iodine one. Who's the lowest between the two? I mean, which one would you select?
The second one?
Okay, so it's this one, right? Because you got 10 2 plus, so that's your lowest, right? So basically, your reaction now is that the electrons are already balanced, so it's I2. The other one is 10 2 plus, and the product is the first one, it's 2i minus 1. The second one, it's 10 4 plus. So I got both my equations. So what has happened is that in the first reaction, 10 turned into 10 2 plus, but then the reaction did not stop. Then the 10 2 plus further turned into 10 4 plus. Is this clear?
Yep, it's clear.
And you can make an overall equation now, add up the two equations. When you do that, the left side is 10, and there is 2i2 because there's i2 in the first one. यहाँ पे भी है, यहाँ पे भी है, ठीक है? And there is on the left side there's 10 2 plus. Add up the products. In the first one, you're getting 10 2 plus, and you're getting 4i minus 1, and you're getting 10 4 plus as well. The 10 2 plus is going to get cancelled out. So without the 10 2 plus, so you get rid of the 10 2 plus. So you get rid of the 10 2 plus, and ठीक है, तो ये आपका आ गया reaction. Is this clear?
Yep, it's clear.
ठीक है, so normally they don't really ask these questions. They can be asked, but like after 5 6 years. maybe one question on this. So try this could be a bit. This could be a bit challenging. So try doing. I'm already telling you that this one is a chain reaction. I think it was vanadium plus excess iodine. So in this one, there would probably be 3 reactions. Like vanadium will first turn into something, then it will turn into something else, then it will turn into something else. iodine tin का हो रहा है ना यहाँ पे, तो something similar would happen. ठीक है, तो ये homework है. Try attempting this one. The first reaction is easy because there's just 2 equations. Then what happens after the first one? Then what happens after the second one? ठीक है, is this clear?
Okay.
So ठीक है, try and send me the solution for this one. ठीक है,
Okay, I'll send it. Okay.
चलो ठीक है, चलो ओके बता.
Okay, thank you, Allah
ठीक है,
Hafiz.
अल्लाह हाफिज़.